Hey everyone, we'll get started in a minute. I think we have already 15 people in here, so just give it a minute or two and we'll get started. All right, let's see if we get to 30 and then I'll kick us off here. Just stuck on 29. All right, there we go, 30, 31. All right, let's get started. We're recording, so if anyone misses the beginning, they can catch up later. Welcome to Protocol Designer 8.5 webinar. I'm your speaker, Mike Cardarelli. I'm the product manager on the authorship tools at Opentrons. So that's Protocol Designer, Opentrons AI, Protocol Library. We're going to talk about Protocol Designer and Opentrons AI today in a lot of depth. Let's get into it. There's a lot to cover. So the agenda for today, we're going to talk about the UX improvements that we've made in the 8.5 release, and then two big new features, huge new features, liquid classes and Python export from Protocol Designer. And then we'll end with a little sneak preview of a couple things coming up. First of all, I just want to share the feedback form for Protocol Designer. This is just a simple Google form. I just want to hear from you if you're a Protocol Designer user. What do you like? What do you not like? What would you like in the future? This is very important for us, and I'll kind of get into why when we get into the upcoming slides about UX improvements. First, I'm going to start with a demo. Let's make a protocol today that we're going to use in the rest of the time. So here's a little example of a manual protocol that a lab might have. This is very simple. This is just an Opentrons Flex protocol that uses the 8-channel, has 3 labware, 3 steps, 2 liquids. You can go to Opentrons AI and just paste this in. If you're like a lab that's using automation with an Opentrons robot for the first time, you have a manual protocol, part of your SOP, but you've never automated it before. Take all of this information about your hardware, labware, liquid steps, and you can go to Opentrons AI, say, I want to create a new protocol. Just start entering it in. So in this situation, I want to use a Protocol Designer protocol because I want to be able to inspect it and validate it visually. But you can choose a Python protocol and go that way if you're more comfortable with Python. I'm not going to click through everything here, but you can kind of see it's just like a form that you have to fill out all the required fields. If you filled out all the required fields, you're going to get a good protocol back from Opentrons AI. So here's everything filled out for my manual protocol. You can see all the hardware, the labware and liquids, and then the 3 steps. So let's hit submit. This takes about 70 seconds. It's a little longer for Protocol Designer protocols than Python protocols. But you can see, you know, this is like everything our Opentrons AI tool needs to create a runnable protocol for your robot. While we wait, why don't I show you, well, I guess I'll see if there's any questions yet. Nothing yet, but please chime in if there's anything that's unclear. I'm going to move pretty fast today just because we have a lot to cover. Okay, we'll just give it another minute. I need like hold music or something. All right, here we go. So here's the protocol I generated for you. Okay. So you can see like this is our protocol. It's kind of folded into like a nice accordion here. If you click into it, you can see how gnarly this is. It's like a huge blob of JSON with all of that information in it. Not very human readable. Opentrons AI has said, like, you know, as you requested, it has a trash bin, it has this labware in the slots that we wanted, it has our 2 liquids, it has our 3 steps. So let's download it. And then let's bring it into Protocol Designer. So this is our no-code GUI tool. It's been around for a while. You can write protocols even if you don't know how to write Python scripts. Sorry, I'm kind of in the way here. So why don't I move over so you can see the deck map. So there's our 3 labware. Here's our 2 liquids. Trash bin, 3 steps. Let's go in here and just take a look. So in our protocol, we said, hey, we want to do a transfer with a 10 microliter air gap and a 5 microliter disposal volume. Let's just make sure it's doing what we wanted it to do. So we go back to Protocol Designer. Let's dig into that first step there. I got to move myself. All right, so we said 10 microliter air gap. Let's check out the aspiration settings. Okay, here we go. Yeah, there it is, 10. Now you can change that. You could say, oh, I want it to be 25 and hit save, and that's fine. Let's go to the dispense settings and check out the disposal volume. Yeah, here it is. So this is just a nice way to visually inspect and make sure that your manual protocol has been matched by this Opentrons protocol that we've created. If everything looks good, you can export it and then run it on your robot. Are there any questions? There's a couple in the Q&A. Okay. Is this processing the protocol with an LLM behind the scenes? Is the formatting required pretty strict on the input text? Yeah, Opentrons AI is using an LLM behind the scenes. Is the formatting required pretty strict on the input text? I'm not sure what you mean there. But yeah, I mean, on the Opentrons AI side, you just have to fill out the form. As far as importing the protocol, it has to follow a protocol designer format. Is it possible to upload a PDF file and also generate a protocol? Yes, it is possible on the newest release of Opentrons AI to import files. So you can import, say, like a reagent kit PDF. So the tough thing there is like some of those reagent kit PDFs are like 30 pages long. It's going to be a lot of tokens. I would screenshot the manual steps part of it and upload that, or just take 1 page out of the PDF or however long the steps are and do it that way. So I'm going to keep going here. Okay, so I'm going to just export this protocol and then we're going to use it later. So just give me 1 second. Just exporting. Okay. Now let's use this protocol to, I'm going to kind of explain what the UX improvements were in the latest release. It's a lot easier to see it than just talk about it. All right, so there's a bunch of UX improvements. Now, if you remember, about a year, not quite a year, I think it was the end of last year, we released a total redesign of Protocol Designer. It had been years. Protocol Designer used to look a lot different than the rest of our products. Now we're using shared components, so there's a consistent look and feel across Protocol Designer, the Opentrons desktop app, and the touchscreen on the Flex. So that was a big shift, and I think, as you know, happens with all redesigns of digital products, a lot of things were better, but not 100%. I think some of the stuff like wasn't quite right, and we kind of knew that. So that's why we want your feedback. That's why we have these feedback forms. That's why we ask for it on these webinars. So I want to go through a couple of things that we changed that I think are in a lot better shape now. So the using setting up your labware in liquids, I think is much better in 8.5. There's a new side panel. I'll kind of show you in a second what this looks like for adding labware and liquids to deck slots. And I'll actually show you what this looked like in the old version because it's showing it is easier than talking about it. And then there's better support for stacking labware, adapters. There's a lot you can do in a slot. It's not just a labware. So you might have adapter slot, and in the future, lids. Those are coming out in the next couple of weeks. So there's all of this like verticality in slots that was very hard to set up and kind of understand in the old design. So here's the new way to do it. Like if you go to the starting deck slot, you can add labware, and then you see this side panel where you can select any labware. Once you've selected it, you can add liquids like very easily here. And, you can select your wells and choose one of, these are one of the two liquids that we defined. So much easier. If you go to the old version, I have like an old version here. This is before 8.5. If you said edit slot, we kind of brought you to this side panel that was mixing hardware and labware, and it was like always defaulting to hardware. And it was very confusing. It turns out in our customer feedback that we were getting. So we've stripped this out, and now hardware lives in its own section. And if you're adding something to the slot here, you're always getting the labware adapters and lids, and it's just like a lot more clean than having to like click twice to get into labware. So that's one nice change. The other thing I would say here is like the stacking is very important because we're launching a labware or the Flex stacker. It's like shipping, I think, any minute now, or some of them have already shipped. So you can buy that already on the store, and it's like a very popular new module that we're launching. So you can stack, multiple plates with different liquids in every one, multiple tip racks. So we need to be able to do that very easily in Protocol Designer. And so that's why this looks the way that it does, where you can kind of see the bottom of the stack clearly here and then the top of the stack and setting everything up. So I'm going to keep going. There's a lot to cover. Okay, this is a big piece of feedback that we got the last time we did a Protocol Designer webinar. And I have a quote from someone who was on the webinar. You might be on the webinar right now, for all we know. I do not like that the protocol starting deck and the protocol steps feel like separate tabs. In the original Protocol Designer, the starting deck was just the first step. I think that simplifies the process. This was great feedback, and I have to agree. If you look at the old version of Protocol Designer, the protocol starting deck was up here in a tab, and then the steps were here. And so if you wanted to say add a module or add a labware to the starting deck state, you couldn't do it here anymore. If you clicked here, there's nothing. When you click on the deck, it felt kind of broken. You had to go back here, and then you could like say add a module or labware. Now you just go, let me just, sorry, just gonna move this. I have like Zoom windows covering up what I'm trying to do here. Okay. Here we go. So if you go here now, you can look at the individual steps, but you can go to the starting deck here and just easily add a labware. So this is all these slots are interactable now. The other thing is the modules or the hardware. It's much simpler to set up. So this is a customer quote. How do I adjust the deck setup? Because our modules might be in different slots. I'm not sure how to edit where the modules are within PD. So it was very confusing to find the starting deck state. And now you can just go in here. There's this is always here, deck hardware. You can come in here, and this is the same UX pattern that we use on the Flex touchscreen and the Opentrons desktop app when you are setting up your robot configuration. So if you're using staging area slots, if you're using a waste chute, if you're using any kind of modules, you can add them here. Like if we wanted to add a thermocycler, you add it here. And this is just a very consistent experience. So in user testing of 8.5, this has been performing much better than the previous experience. Okay, I'm going to keep going. This is more customer feedback. You'll see a theme here. We want to hear from you. So on the I think it was maybe 2 webinars ago when I was talking about the protocol designer webinar, the protocol designer redesign webinar. Someone asked, can you show the tip rack colors on the deck map? And it's not something I had really thought about, but yes, we could, and we did. So you're going to see all the different Opentrons tip rack colors on the deck map for Protocol Designer and now Protocol Library, Opentrons desktop app, and Flex touchscreen. So across the board, this makes it so much easier to do deck setup. And then this is, I think, maybe the best thing that's changed as far as like the user experience on Protocol Designer 8.5. The per slot liquid information. I'll show you what this looks like, but it was very helpful for us to check the composition of our mixtures at the end of the protocol. I think being able to see the final liquid volumes should come back. So we added final liquid volumes, but also every intermediate step. So this is something that was lost in the protocol designer redesign. But you can see, like, let's go back to the old version. You can't really see anything in the ending deck state. But in the new one, if you go to the ending deck state, you can click here and see every well what liquids are there. And you can see, like, this is serial dilution. So in the sample, for the sample liquid, you can see how the volumes get smaller as you go across rows. And then for the diluent, you can see the volumes get larger as you go across rows. So this is super helpful. And this also works at every intermediate step. So you can say, all right, step 1, what does this look like? Looks like this. I only have samples. There's no diluent yet. Step 2, we have a little bit. And then, step 3. So this is very helpful just to validate that this protocol is doing what you want it to do. Again, feedback from a customer that we're able to make this change. Okay. One last thing, as far as UX improvements, then we'll get into the new features. It was hard to see what liquid you were transferring. We were saying, oh, you're transferring from here to here, but we weren't saying exactly what liquid was being transferred. So we're showing here, this is now a mixture of the 2 liquids is being transferred. This is the diluent. So this is also very important now because we have liquid classes, and that's a good segue to the next section. So 2 big new features. Liquid classes. This has been a huge request. I think people who've used automation before are kind of used to this, and it's something Opentrons up until this point had gotten away with not having. People would just sort of did it themselves, and a lot of our protocol library protocols kind of had this logic built into them, but we never had like clear liquid classes. So our hardware and science team spent, I think it ended up being about a year working on this, and the amount of data they produced is like incredible. So I feel very confident you're going to get good results if you're using these. Here's like kind of the quotes that explain why this was important. Want to be able to input liquid class pipetting parameters on the liquids tab of PD. I want liquid class definitions in PD, settings for liquid classes that are predefined. So some of you are probably very aware of this kind of feature from competitor products. But here's what's changed. 3 new liquid classes for Opentrons Flex pipettes: aqueous, volatile, and viscous. So those 3 should cover a lot of what you need to do. There will be ones in the future. People have asked about detergents. There's other kind of stuff. We just have to complete the testing, but we're launching with 3. And these 3 will be better than before, which was nothing. A lot had to be refactored for the steps in, if you use Protocol Designer in the past, you'll kind of see a lot has changed as far as the step forms for transfers and mixes. There's a lot of new parameters. And I'll kind of explain like a couple things to be aware of with that change. And then there are limitations. So there's no custom liquid classes yet. That's something that's on our roadmap. We want you to be able to make your own or make it, adjustments easily. And you can do that in Python right now, but not in Protocol Designer yet. And then OT-2 liquid classes, we're launching Flex liquid classes here, but not OT-2. But in the future, we're going to make it easy for you to make your own OT-2 liquid classes. Are there any questions? Okay, there's a couple. Maybe I'll pause here. Why don't I come back to these and I'll just kind of get through this first. Okay, here's what it looks like to add a liquid. So if you go into the liquids panel here, you can put the name, the description, and now this is, and the color. You could do that, all that before. Now you can choose one of those 3 liquid classes, or you can say don't use a liquid class. The nice thing about this is if you say, this is a viscous liquid, this is, a sample or something, the transfer step that you make, if you select that liquid in that step, it will automatically apply the liquid class for viscous. So it makes it very easy. We can kind of show you what that looks like. So if you go into like liquids here, all right, let's say, by default, it says don't use a liquid class. We can say, hey, actually, we want to use this one. And then every time you do a transfer or mix using that liquid, it'll apply that. So it's very nice. And then you can also see, like, let's see, if you go to the next one, this is all the things that have changed with the transfer step. So it's like 3-step kind of flow here. You set the volumes, the wells, the pipette, the tips, all that stuff in the first step. Second step, you select your liquid class. That's important because depending on your volume, the destination and the source and destination wells, the pipette tips, the pipette, depending on what you've selected, the liquid class will give different values for the 3rd step. So it's very specific to, the liquid class behaves differently if you're using a large amount of liquid versus a small amount of liquid. All of these things matter. So that's why it's set up this way. And you might get confused because you might say, well, on this, third part of the form here, sometimes this value for flow rate is different than on some other step. It's because the liquid class is making those changes for what this 3rd step of the flow is. So that's basically what it looks like. So there's that liquids modal or panel, and then there's the actual steps for transfers and mixes. And that's where you select your liquid classes. Any questions about liquid classes before we move on? Let's see. Okay, I am on the protocol designer for OT-2 at the moment, but I don't see an option for liquid classes. Is this only for the Flex? Yes. And then the OT-2 in the future, I think the plan is to have a custom liquid classes option, but not in the near term any kind of predefined liquid classes. This is the Flex pipettes are very different from the OT-2 pipettes, so we're not able to take what we learned from the Flex hardware and science testing and just apply it to the OT-2. But we want to make it so that people can make their own and make tweaks easily. Okay, I'm gonna keep going here. This is the other big change, Python export from Protocol Designer. We did a bunch of research for the Protocol Designer redesign last year, and we, wanted to hear from our users. We had a bunch of interviews and on-site visits, and the biggest request wasn't about the user interface at all. It was about the file format. So if I have a protocol made with Protocol Designer, can it be converted automatically to a Python file? That way I can compensate for features that aren't in Protocol Designer yet. So that's one thing I think, previously we exported a JSON file, which was not human readable or editable. And it made it tough because you might have a lab where some people are comfortable with Python, some people aren't, and they were kind of siloed into different experiences, and there was no way to cross that. So like someone who, maybe you have an automation engineer who lives and breathes Python, and then you have someone who is writing protocols in Protocol Designer and not super comfortable in writing Python scripts. They couldn't really collaborate. But now that we export Python, you can say, hand off a protocol from Protocol Designer to an automation engineer. It really makes our platform, our software platform, much more compatible with itself, and you don't have these two parallel paths to the robot anymore. So I'll show you what that means for Opentrons workflows. It's a pretty big change, even though you might not even notice it unless you're looking at this exported protocol file closely. So if you hit the export button now, the JSON export is gone. There's no option to choose JSON versus Python. It exports Python now. If you export from Protocol Designer and you open it in a text editor, this is what it looks like. It looks like Python, just like if you downloaded a Python protocol from Protocol Library, or if someone in your lab wrote a Python protocol. So the thing about this is, like, what does this change? It changes a lot, I think. So new things you can do now with this. Right? Let me move myself out of the way. Hold on. So you can now export from Protocol Designer, open it in a code editor, and make changes, or hand it to someone in your lab who knows how to write Python and have them make changes, and then run it on an OT-2 or a Flex. If you're not comfortable writing Python yourself, you can also go and import it to Opentrons AI. I mean, these LLMs are so good at writing Python, especially. So you can export from Protocol Designer, import it into Opentrons AI, ask it to make changes, because there's things that you can do with Python. Obviously, Python is like super powerful, full programming language. There's all kinds of stuff you can do that you can't do in Protocol Designer. You can't do if-else statements, for loops, all that kind of like powerful programmatic logic stuff that you can do with a full programming language. There's also things like runtime parameters that you can't do in Protocol Designer. It would be very hard to do in a no-code visual tool, but it's very easy to do with Opentrons AI or other kind of LLM coding assistants. So this is pretty powerful. I think, like, I want to show like a little proof of concept for this, but we really want to see like what our community does with these kind of new workflows. So let's go back to Opentrons AI, and I'm going to just show you how to add runtime parameters to a Protocol Designer protocol. So let's go back to, let's see, that's where we were. Let me just go here. All right, so we went through this first flow, help with a new protocol. So we kind of went through and started from scratch. But interesting thing that we've seen in our analytics is more people actually do the update flow. We built this as like a secondary flow, and we built this as a primary flow. We thought, well, people are going to have like we're going to want to create brand new protocols. And that's like the most important thing. So that's like the first thing that we would put on this page. But it turns out more of you want to update an existing protocol. Maybe it's something in your lab that you have already. Maybe it's something that you found on protocol library and you're downloading it in here, but you need to make some changes. So maybe it's a reagent kit and you have the manual steps in there and you want to just like paste it in Opentrons AI and go from there. So let's do that. Let's do that flow. So we're going to update a protocol. So let's take our protocol that we just generated, the demo one. Just going to choose a file. Okay, there's our demo. And then just going to go back here. I wrote this like beforehand, like let's add two runtime parameters. So here's what we're going to do. Type of update, runtime parameters. All right, so here's what I wrote. I'll just read it. I need help adding two runtime parameters to this protocol. One runtime parameter for setting the pipette on the right mount or left mount. This is like a common thing people do, is write the pipette mount as a runtime parameter so they don't have to detach and reattach a pipette that might be on the wrong side. So just have that as an option to change before you run the protocol. And then I said the default value should be the left mount. And then one runtime parameter for setting the volume of the sample liquid in the first column of the well plate. The acceptable range should be 25 to 100 microliters, and the default value should be 100, which is what it is. So let's submit that. You can see our, not sure. Okay, I don't know why that, anyway, demo effect, it's working now. So here's our prompt. This is our original protocol. You can see the Python. This is the labware being loaded. I think Python is a little scary if you're not comfortable with it, but it's pretty readable. Here's our pipettes. We have it on the left. This is something we want to change into a runtime parameter. Trash bin, liquids, which is us loading our liquids in the well plates. And then our 3 steps. Step 1, step 2, step 3. So it looks complicated, but it's not that bad. The thing about some of these coding, I mean, this was generated by protocol designers, so it's very well commented and very well structured. And then Opentrons AI does the same thing. It has more patience for code comments than a lot of times a human coder would. So it's kind of interesting how these things have caught on. Let me see if there's any questions about. So I guess, yeah, maybe I can look at some of these. Can you upload a matrix via an Excel file, like a 2D table, what to mix with what, telling them where the reactants are sought? You can't, yeah. So you can now, so this is something new, and maybe this is something that we'll cover in the next webinar for Opentrons AI. I think we'll do one in a couple months. We added an ability to attach files in chat. And so one of the reasons was for reagent kit PDFs, but the other reason was for CSVs. So that's something that is enabled now, and maybe I can demo that next time we do a webinar. But try it out. It's a new edition. I believe it's in production already, but I can check that. And then regarding UX, could we click a step and then have the edit step panel pop up automatically instead of having to right click and click edit every time, since I don't really have a reason to just left click? Yeah, that's great feedback. I'll log that one, John. Okay, here we go. We got our protocol back. Here's your updated protocol with the requested runtime parameters. Okay, so this didn't change. This is new. So here's our two runtime parameters. So parameter for pipette mount selection. So we have left and right now, and then we default to left. So this is called pipette mount. So now if you go down to where we're setting up our hardware in the protocol here, we're using this as our variable for pipette mount. Let me see here. And then you can see, liquids, trash bin. Okay, yeah, here. So then when we're loading our pipettes, we're using that variable here. Instead of saying like left, we're using the runtime parameter value. And then for sample count, or sorry, not for sample count, for sample volume, we said the range, so minimum 25, maximum 100, and default 100. And now this is called sample volume. So when we are defining our liquids in the well plate, you can see here is our well plate. And for volume, instead of saying 100, we're using that variable for sample volume. So I could go, I just don't want to switch the screen sharing right now, but if you took this into the Opentrons desktop app or the Flex, you can see those runtime parameters pop up on the screen before your run. So that, you see this takes like 70 seconds to, obviously it took me a minute to write what runtime parameters I wanted to add, but this was impossible before. Like the answer of I want to use runtime parameters with protocol designer, it was you can't, you have to use a Python protocol. Well, now you can, and it takes like 2 minutes to add them. So we're really excited to see what you all do with this, but this is a new workflow enabled by this new feature. So technical details, there's like a lot here. Feel free to zone out on this if you're not interested in like the Python under the hood part of what changed. But if you are interested in that stuff, I'm going to just dive into it for a couple minutes. There's limitations with this. So this is more of you go from protocol designer and then you go out. So it's like you do your deck setup, you create your steps, you export. If you want to make changes in Python or you're using Opentrons AI, you make changes and then you go to the robot. But you can't go the other way very easily. So if you create a protocol in Protocol Designer, export it, you can import it back in, no problem. You can't take something off protocol library and import it into protocol designer. It's not going to work. There's a lot that protocol library and any other kind of Python protocols might have as far as like logic, if statements, that we can't really handle in protocol designer. So that's just something that we've seen early on where people are trying to open everything in protocol designer and it's not going to work for you. You can import those things into Opentrons AI though, and that will work fine. If you make changes to your exported protocol, they will take effect. So like we can add runtime parameters and run it on the robot. The robot will read those changes to the Python and it will work fine. But if you take that and then you try to re-import it to protocol designer and see those changes in the Python, see the runtime parameters, for example, or if you made some other change, you're not going to see it because protocol designer is actually reading from a field called designer application. It's at the bottom of the exported protocol. You might not even notice it, but it's a long blob of JSON. So that's something that you might want to know if you're trying to debug. Why did I make it? I made a change in this protocol and then I imported it and I'm not seeing it because you would have had to make a change to that designer application field, the data in there in order to see that. So just wanted to touch on that to make that clear of like how this works You don't need to know how this works, but if you're curious about how this works, and Opentrons customers usually are pretty curious people, I just want to explain that here. There's a couple other things. So the exported Python from Protocol Designer and Liquid classes both required new complex commands. So if you're into the Opentrons Python API, there's like two levels of commands. There's atomic commands, which are like aspirate this, dispense this, very, very atomic, very small, gives you fine-grained control. But then there's complex commands, which kind of are just like, I need a transfer from here to here, this volume. And those are much easier to work with because they're, you don't have to do as much. You can just say, hey, I want to do this, and you don't have to break it up into component parts. The thing is, they were written like these older complex commands were written like 8 years ago. I think the early days, maybe the OT2, maybe OT1 era actually. And I think they were like a good attempt, but as we became a little more advanced in our understanding of liquid handling here, we realized they were pretty limited. So I think the liquid classes team, the hardware and science teams, when they were setting out to say, hey, we're going to make liquid classes, that we need like incredibly detailed control over the movements and behavior of our pipetting, the old complex commands did not have enough control. So now we had to create these new commands, and if you dig into it, you can see there's a lot more fine-grained control. So that's why these things came out at the same time. So we have these new complex commands that's under the hood on Protocol Designer, and liquid classes are also using those. The old complex commands still work and still exist, and you can kind of see I've labeled them legacy here. But if you want to use liquid classes, and if you're using Protocol Designer, these are the new ones. And then the UI, so that's why the UI looks different on Protocol Designer versus the old way before 8.5, because the new forms have to match these new Python functions. So that's why some things changed. I think we got some questions. Let me just finish this technical deep dive, and then I'll swing back around. So liquid classes are going to greatly speed up protocol writing and optimization going forward. But there are some adjustments, especially for users who have a protocol from the past, a PD protocol from the past that they want to import and make changes to. We've seen a couple things that I'm calling like pitfalls. So there are these old fields that Protocol Designer used for blowout locations and delay positions. And you can, I don't know if I'm like in the way here. No, I'm still above it. Okay, so down here, you see Protocol Designer used to count from the bottom, but the Python API and liquid classes and all the new way of doing things counts from the top. So we have this like, it's a bit of like a unsolvable incompatibility, and we did not want to guess where you wanted your tip position to be. So this field is empty now. These fields have been replaced by submerge and retract location. So if you import an old protocol, you're gonna get that has these settings set. You might not. These are optional. These are going to be empty, and so you're going to get an error. But something that's been happening is people are importing these protocols that they know are good because they have run before, and they're trusted protocols, and they're not expecting any errors. So they're coming in and making a change or adding a step, and then they're exporting, and they're not seeing that there's a red error here that's like, hey, you got to enter, the new fields for submerge and retract location. And they're just exporting. And if you export a protocol that has a timeline error, a step error like this, it's just empty because we do not want to break your robot. And so we're not going to create a step that we know is missing information. So if you are in this boat, if you're moving up to Protocol Designer 8.5, just be on the lookout for this. If you see any errors, all you got to do is open that, enter those two fields, and then export. But again, most of you might not even see this because these fields were optional and some people didn't use them. One last thing, these are huge changes. So not everything is exactly the same. You will see different protocol step durations. I've done some benchmarking. It seems like, or it is clear to me that transfer steps are a little slower. There's a lot more accurate movement, I think you'll see if you compare the old PD and new PD. Mixed steps are faster. So if your protocol has a lot of mixed steps and not a lot of transfers, your protocol is going to be a little longer probably. If your protocol has a lot of transfer steps and not a lot of mixes, that protocol will be longer. If your protocol has a lot of mixes and not a lot of transfers, your protocol will be faster. So there is some difference. Don't be alarmed. You'll see though, especially for the transfer, if you watch the pipette, it just feels more accurate the way that it's moving compared to the past. And the testing and the results that we've seen have been really impressive. So I guess the only thing I can say is like someone who saw the product development process is I am very confident in the new values for Protocol Designer, the new defaults. In the old defaults, I think were like a best guess, but they weren't based on data. And the new defaults are based on thousands and thousands and thousands of hours. We have a room that is just doing these tests over and over and over again in the Long Island City office. So feel very confident in the new defaults. I would not be afraid to use them. Okay. Before I go into coming soon, maybe we can talk about some of the questions. Or actually, why don't I keep going and then we'll do questions at the end. Thanks for bearing with me. I know we're almost at an hour here, but there's a lot to cover. Okay, here's what's coming up. I got an asterisk here for anytime I communicate roadmap stuff externally, because I just want to make sure we're caveating this. Things can change. I think the biggest thing for us that changes is there's a very extensive testing process. There's ABR testing and QA testing. Everything has to pass. So if something is delayed as far as a release date here, if we don't hit October, November, January, it's because we found something and the quality is not up to par. And if it isn't, then we're not going to ship it. So October, this is looking, I think these are looking more likely the sooner they are and less likely the further out we are. But I'm confident we can hit all these dates. But the Flex Stacker getting added to Protocol Designer. We're working on this right now. This should be out in I think maybe mid-October, maybe a month from now. The low volume 96 channel is also a new product that will be supported. There's also new lids. So the thermocycler lids in Protocol Designer and the Opentrons universal lids. I think there's actually a couple other lids that are coming out. All of these are very important for the Flex Stacker. So those are coming out, and the ability to stack them. So you could put a stack of lids and have the gripper move them around. Then November, we're doing a lot of advanced tip control stuff in Protocol Designer. So return tips. I do a lot of demos. It is so annoying for me to have to go grab the used tips out of the bin and then put them back in the tip rack. So I feel your pain. This is coming. The ability to, we do a great job in Protocol Designer with automatic tip selection, but sometimes you want to select a specific tip, especially if you're reusing them. So we're going to add manual tip selection. And then concurrent module actions. There's stuff sometimes where you have like blocking commands, especially around like heating modules and things like that. We want to make it easier to do multiple things at once. So this is kind of a bigger change like under the hood, and it'll look fairly simple on the front end. And then later in the year, or probably January, all the liquid level detection stuff that you can do with the Flex, that is not easily, or I guess you can't really leverage it in Protocol Designer. It's coming. You can do this stuff in Python now, but we're adding it. Camera controlled ability to be able to take a picture with the camera during your run. And then all the partial tip pickup stuff. You can do very limited partial tip pickup with the 96 channel in Protocol Designer. We're adding everything else. So these are big changes, but it's going to really allow you to like kind of get the full maximum potential out of your hardware. So a lot of this stuff is easier to do now that we export Python, like return tip. That was going to be very hard to do in the old paradigm, but now it's like trivial to add. So I think we're going to see some like feature development picking up speed now that we've made these changes under the hood. 2 last slides, and then we'll just finish with questions. There's a new offering from our field services, field application scientists team. So if you're in this boat where you're a protocol designer user, or you have a protocol library protocol that you need some help adapting, you're not starting from scratch. So maybe before you weren't interested in getting some help with custom protocol development. We have an offering. It's much less expensive. It's just adapting a protocol. So you have a protocol designer protocol, you have a protocol library protocol, you just need some help, you need an expert. We have an offering here. I'm trying to see. Yeah, so I think reach out to whoever it manages your account, and if you're interested in this. And this is a new thing now that we're in this world where our platform is much more compatible with itself. I think we're seeing a lot of this where it's like our customers don't need a new protocol from scratch. They just need some help adapting something that already exists. And our field services people are incredible here. If you haven't worked with them before, they write more Opentrons protocols than anyone on earth. These are the best in the business, like literally. So they can get you up and running if you need some help making an adaptation to an existing protocol. Last slide is the feedback form. You can be a quote in a future webinar. Let us know what you want. We already got some great feedback in the Q&A. So I log all of this. I have like all the voice of customer that we receive. We log it. It helps us prioritize. I can't guarantee that we're going to fix your request right away, but it's all logged. And we always have to balance new development versus fixing stuff that's already out there. But as you see, like we're kind of doing both right now with new features and UX improvements. So we'll do this again, and hopefully the feedback you give us helps us decide what we will show in that next one. So we have 6 minutes left. Let's see if we can get through these. John said, I was thinking of inputting all my parameters and sample group specific values, e.g. volume of additive to add for low, medium, and high concentration groups via SVZ. Via CSV. Is this doable? Yeah, I think the CSV stuff, if you are exporting, well, if you want to use Protocol Designer, you can export and then build an integration with the CSV using Python or Opentrons AI. People do so much with CSV. It's all about how you format the file, and we give you a lot of flexibility in how you want to format your file. So all of this is possible, John. This is the kind of thing that if you need help, the field services people do this constantly. So these are like experts in this. CSVs are so popular with our customer base, as everyone on this call probably knows already. Okay, next question. So does PD not show the changes to protocol because they're not necessarily updated in the JSON? Yes. or because the protocols are more flexible than the designer UX. I'm wondering if we were generating updated JSONs as well as updating protocols, they would be reflected in PD for debugging. Yeah, I think like in theory, you could maybe have an LLM update the JSON to match your changes in Python. It's going to be pretty brittle though, because if you have anything like a for loop that we don't have a way to represent in protocol designer, it's going to probably crash the application. So I would not go down that road. But yes, you're understanding it correctly. So if you did change that JSON blob at the bottom of the protocol, that is what protocol designer is reading, but it's going to be very difficult to keep those two things in sync, I guess. Sorry, I know we're almost out of time. I just want to get through the last three here. We cannot run the protocol designer on the computer we are using to run the robot due to IT security restrictions. Have you ever thought of making it possible to be able to make changes on the protocol outside of PD, no matter if in the interface between the robot and computer or on the robot itself? Yeah, their offline PD version, there is like if you download Protocol Designer and then turn off your internet, it will still work. Like it's got everything it needs. So there's ways to run Protocol Designer offline. We have customers in a similar boat. So Sabine, I would maybe reach out to support and we can get you some help there. Chuck said, I used the new version designer and noticed that there's no longer a way to adjust the blowout height after liquid transferring. Is there still a way to adjust it? That is the retract position, Chuck. So you can you should be able to do that, but let me know if that doesn't work for you. And then Tobias said, will the return tip option also include the possibility to return tips that were taken in partial mode in case of using the 96 head? Yes. So right now, even with Python, you can't return tips with partial tip pickup. We're changing that in the Python API. So when Protocol Designer gets these more more options for partial tip pickup, that the return tip will also work for that. That's a great question. And then Evan said, with regards to the 96 head and flex, is it possible to design using each row and column independently? Yeah, so you can use the single column right now, only the rightmost column. I think it's like column H. But in the future, what we're working on is the right column, the left column, the bottom row, the top row, the 4 single tips on the edges. And that's it though. No like 48 pickup, no 24 pickup. I think that's something maybe in the future, but we'd have to do more hardware testing. There's issues when you start getting into 24 pickup. I think maybe 24 works okay, but 48 pickup, the force required is a lot on the 96 channel. So then you get into worries about like breaking your tip boxes and stuff like that. So people ask about that a lot. That's why it's not supported right now in the Python API. I think that's all the questions. Thanks so much for sitting through this. We have 1 minute left, so we made it. Okay, one last question. Any plan to update the Opentrons app in the future to accept any input? Well, let's follow up afterward. I'm not sure, Davide, what you mean there, but we can maybe go in a little depth afterwards. All right, cool. I'm gonna sign off. We'll be back. I don't know the exact date, but I think we'll do something on Opentrons AI coming up, and then maybe after that we'll do another protocol designer one. So thanks again, and I'll see you soon.